Yesterday, we asked you at home to submit your questions that you had about El Nino. It's pretty complicated, and we got a lot of those questions sent in, so we thought it would be best to bring in the heavy hitters.
That's right. We've got joining now for a special panel here on Weather Command. We have Dr. Amy Clement joining us. Amy's a professor at the Rosenstiel School from the University of Miami. And then you know that other face right next to me, Fox Weather Hurricane Specialist Bryan Norcross. So we do want to jump right into it, guys, because we are on a clock here on live television. So, Amy, I want to kick it off with you. Let's just establish what it is, but more importantly, how it got its name. The first question we've chosen, this one's from Brandy. And Brandy asking us, how did El Nino get its name?
Yeah, great question. And hi, everyone. Nice to see you again, Bryan, and others. So
nice
El Nino got its name. El Nino got its name because the peak of the event tends to happen right around Christmas time. So tends to be like the Northern Hemisphere winter time. Peruvian fishermen were observing this as the event would evolve, it would impact the fish that they were fishing for. Many of the species changed, and it also changed the weather patterns in Peru. And so they named it El Nino after, in honor of Christmas time.
It is an interesting story. We talk about El Nino, sometimes we talk about La Nina, and sometimes we talk about neutral, the three phases of Enzo. The next question I have, and thank you, Amy, for that, this one then goes to Bryan, because our next question, this one is from Dixon in Idaho, and Dixon wanted to know, how do these El Nino conditions in the Pacific impact the Atlantic basin?
Well, remember, the El Nino is warming of the water. The warmer the water is, remember, heat rises. So if the water is warm, the air above the water is warm, that air is rising. So that rising air has to go somewhere, and it actually cycles up and comes down and suppresses activity in the Atlantic. It's got to do with the circulation that has to do with where the warmest water is. So wherever the warmest water happens to be, that air goes up. And then it comes down over the Atlantic in this case. It also causes upper level winds that are hostile to development. So those two factors work together. It also affects the wind pattern over the Atlantic and can actually make the Atlantic cooler because of lighter trade winds as well. If you think about what's going on there and how the air is flowing around, but mostly it's the suppressing effect and the upper level winds that causes the diminished hurricane activity.
Yeah, the European forecast model coming out with their seasonal outlooks, and that sheer is evident on those models. Amy, with the knowledge you have about El Nino, we had a bunch of questions coming out of the western U.S. A lot of people asking about a host of different things. We were clumping them all together, and we're just going to serve them to you on a platter. So this was from Jen in Denver asking, what impact will El Nino have in the Rockies and the Front Range? We also had Thomas from Wyoming. He asked, with the Super El Nino looming, are we going to see significant, much-needed snowpack this upcoming winter? He went on to say that they desperately need it in Cody, Wyoming, and that's been a theme that we've heard throughout the Rockies. And then Charlie had an interesting take because he talked a little more synoptically about this. Where would what he called the Alaska low be positioned in an El Nino year? The reason why he's asking that is because that would often maximize the rain and snowmelt water available to reservoirs like Lake Powell and Lake Mead, as well as the Southwest. So you get the drift. We need moisture in the West. Is this going to help?
Yeah, so that's a great question. I'll just build on what Bryan talked about earlier. El Nino has this, it's centered in the equatorial Pacific, but it has these global impacts. So the air above the warm water, it radiates out, and it affects the northern hemisphere. And you can see that here the jet this jet stream tends to shift to the south, which typically means that the Rockies and the upper U.S. and Canada tend to be warmer and drier during El Nino winter. So that's probably not good news for the snowpack. And on top of that, it's important to remember that we are experiencing ongoing climate change with warming climates. So while this is a temporary a temporary reorganization of the jet stream for this year, it's on top of a persistently warming climate, which is also not good news for snowpack. I'm not making a prediction. El Nino, it's important to say, only shifts the probabilities somewhat of of how the weather systems are going to evolve over the winter time. But statistically, this is moving the upper half of the U.S. towards a warmer and drier winter. The southern half of the U.S. will tend to be a wetter and cooler winter.
Yeah, and then to see how it does translate eventually into the mountains when it comes to snow and to rain that we could see elsewhere. Yeah, dependency on the reservoirs for water supply, and also just a really tough winter that we came out of, economically speaking, for many of these locations. Bryan, I'm going to switch it back over to you. So you joined us at the top of the hour, and I know you know this. Colorado State University just released the updated hurricane season outlook. This is it's another year in recent memory where the strength of that this El Nino could play a significant role, is playing a significant role, it looks like, in the CSU forecast. We talked about the numbers at the top, but they did bring those numbers down.
Yeah, reflecting the El Nino forecast. As we move closer to the peak of the hurricane season, we just have a better understanding of what the El Nino is going to do. So in the spring, there's something that would be wonderful if Amy could explain this better than I can, the spring predictability barrier on El Nino, because the triggering effects are subtle. And so as those forecasts have come in and become clearer now that it is going to be at least a strong El Nino, if not a very strong so-called super El Nino, that means that the hurricane season forecasts have come down as the El Nino certainty has gone up. It's really that correlation. It's not any more complicated than that. And when we get the NOAA updated forecast coming out next month, I think they'll probably edge their numbers down as well, again reflecting more certainty in the El Nino forecast.
Yeah, Amy, go ahead. Explain a bit of that spring predictability barrier and the challenges that are faced. I had mentioned that the European, one of the global forecast models, we used the graphic when you were talking about what the West could experience. We get these outlooks every month. They can go out to 13 months when you look at the global models. But there are challenges when trying to forecast seasonally, significant ones.
Right. And historically, we've been predicting El Nino events really since the 80s. And the reason we can do this is because we have this wonderful observational network that's out there monitoring temperatures in the ocean and the atmosphere and subtle shifts in the winds. And looking back historically, we've been making these forecasts. They don't do so well if we start the forecast early in the calendar year, so like January, February. But as we move through the spring, the forecast skill starts to improve. Why is still a good question, is still an open science question. Sorry, Bryan, I don't have a simple answer for you. I tend to think of it as sort of, the system is a little unstable. It could go this way, it could go that way. I think, as you mentioned, like a little flick one way or the other might tip it, could tip it into the El Nino or out. But what we have here is we're past that predictability barrier. Things are all headed in one direction. All the models are headed in one direction. It seems pretty clear what's going on. Yeah, this is a great graphic. We don't see this kind of model convergence very often.
Yeah, 100% chance that we get those waters to warm above 2 degrees Celsius. We are about out of time, but we've also had a voice on, and Amy and Bryan, I'm sure you're aware who he is, Andy Hazelton. He's with the University of Miami as well. We had him on yesterday, and we posed the challenging question of, okay, so with these predicted storms this season, when could we see them? Is it early in the season, the middle of the season, toward the end of it? And that's with the knowledge that we had yesterday. Let's roll that soundbite, and Bryan, we'll talk about it on the other side.
Typically, in El Nino seasons like this, what you see is sort of most of the activity is maybe on the front half, or at least concentrated near peak. So I think it's, July being quiet in the Atlantic is normal even in a non-El Nino year. So I think as we get into August and September, you look for that narrow window where maybe we get a big storm to try to come across into the Southwest Atlantic where waters are warm. So, kind of near peak seasons where I would expect the activity this year in the Atlantic.
Not trying to corner you, Bryan, but he said August, September, which is close to that peak season. I mean, from what we know, you think that's a fair assessment?
Yeah, that's a fair assessment because the more favorable part of the Atlantic is going to be in the subtropics. So when you get late in the season, first of all, the El Nino is going to be stronger, so that's going to tend to want to cut things off early. And secondly, you get cold fronts coming down and kind of making some locations a little more hostile. So I would think that if we get a track, kind of looking at the tracks you're showing there, north of the islands, up into the air, the waters off Florida, maybe into the Gulf, something like that, that's where the conditions are going to most likely be the most conducive, and the overall pattern just gets worse as you get later on in hurricane season as the El Nino really kicks in.
Well, a fascinating discussion, and one, unfortunately, we're out of time now, but we're not done talking about it as we get further into the season. More than 20 weeks to go, or about 20 weeks to go for the Atlantic hurricane season. But also, as we know, this El Nino, this strengthening El Nino will have probably some big implications when we get into fall and winter. So we appreciate both of you joining in on the conversation this morning. Professor at the University of Miami, Amy Clement, Dr. Amy Clement, and then Fox Weather Hurricane Specialist Bryan Norcross. Thank you both. And Weather Command will be right back after this break. Thanks, guys.